So lesson 15, exercise 1 says determine whether each claim given below is true or false. Part A, right now I am in math class and English class. You can't be in two places at once, so this statement is false. The key word here is and. We'll come back to this in just a second. Part B, right now I am in math class or English class. Okay, this statement is true, because think about it. You can be in one place without being in the other. So the key word here is or. So if you look at the differences between A and B, it's the key words and or. And means that both conditions have to be true in order for the statement to be true. Or means that only one condition has to be true. So keeping that same thought process, look at C. 3 plus 5 is 8. 8 equals 8. So this is a true statement. 5 is less than 7 minus 1. So 5 is less than 6. This is also true. Again, our keyword here is and meaning that both statements have to be true in order for this to be true. And in this case, they are, so this is true. Look at D. 10 plus 2 is 12. So bring down the not equal symbol, 12. 12 does not equal 12. That is false. 8 minus 3 is 5. 5 is greater than 0. That is true. Our keyword here is and. And means that both statements have to be true. And in this case, they aren't. So this would be false. Look at part E. 3 is less than 5 plus 4, which makes 9. 3 is less than 9 is true. 6 plus 4 is 10. 10 equals 9 is false. The key word here is or. Or means that only one condition has to be true. And in this case it is, which makes this example true. 16 minus 20 is negative 4. Negative 4 is greater than 1 is false. 5.5 and 4.5 make 10. 10 equals 11 is false. Keyword here is or. Or means that only one condition needs to be true. In this case, they're both false, which means we have no solution, or it would be false. Same exercise 1, part G. When the two declarations in the sentences above were separated by the word and, what had to be true to make the statement true? So again, focusing on those key words, and means that both statements have to be true. On the flip side, when they're separated by the keyword or, only one has to be true. Look at example 1. Solve each system of equations and inequalities. A system simply means that it's two or more equations or two or more inequalities. Part A, x plus 8 equals 3 or x minus 6 equals 2. All you do is simply solve both equations or inequalities, but it's equations in this case. So first solve both of them. X plus 8 equals 3. We have to isolate the variable if we're solving, so we need to subtract 8 on both sides, which means we are left with x equals negative 5. If you look at the other equation, to isolate the variable, we need to add 6. So we have x is equal to 8. The key word here is or, and or means that we can have two solutions. So all we're going to do is take both of our answers and write them in set notation. So our answer is negative 5, 8. Part B. Again, first start with solving. To isolate the variable bit by bit, we're first going to add 9 to both sides. which gives us 4x equals 9. To isolate the x, we divide by 4. 9 doesn't divide by 4 evenly, so we leave it as a fraction. Look at the other equation. We're first going to subtract 5. So we have 3x equals negative 3. To isolate the variable, again, we'll divide by 3, and we're left with x equals negative 1. Our keyword here again is or, and or means that we can have two solutions. So all we're going to do is write our solutions in set notation form. Another thing I'd like to note is that it actually doesn't matter which order you write your solutions in inside set notation, but it's highly recommended that you go ahead and get in the habit and practice of writing them from least to greatest. So let's look at part C. X minus 6 equals 1. Again, we're going to solve this equation. To isolate the variable, we're going to add 6 to both sides. So we're left with x equals 7. When we solve the other one, to isolate the variable, we're going to subtract 2 on both sides. So we're left with x equals 7. The key word here this time is and. So on or statements like A and B, we were allowed to have two solutions. With and, we can only have one solution. And in this case, our solution matches, which means that actually is our solution. X equals 7. Part D. 2w minus 8 equals 10. We're first going to add the 8 to both sides to work bit by bit since isolating our variable. So we're left with 2w equals 18. To isolate the variable, we would divide by 2. W equals 9. The other one, w greater than 9, that's already solved because the variable is by itself. So we need to think about what that means. W greater than 9 means it does not equal 9, and if it did, they would have put the bar underneath the symbol. So this would mean numbers like 10, 11, 12, and so on. The key word here in this equation or system is and again. And means that we can only have one solution. So on part C, our solutions matched, so that's how we were able to give the answer of 7. But on D, our solutions do not match, and since they don't match, our answer is no solution. Exercise 2. Graph the inequality x is less than 3. Less than is not equal to, so we're going to leave it as an open circle, and it means less than, which means we're heading left on our number line. Part B, x is greater than negative 1. Open circle again, it's greater than, so we're heading to the right. Part C says, darken the section of the number line where x is less than 3 and x is greater than negative 1. So x is less than 3 would be this red part, so we would be heading this way from this red circle. And x is greater than negative 1 would be to the right of this purple dot, purple circle. So if you look where my arrows are, I need to darken this middle section between the two open circles. So if you were ever asked to graph this, the correct answer would be a number line with those 2 points, and you would have an open circle, and just that shaded part in between. You wouldn't want all this other extra shading that you had on this original problem. So look at D. Graph the inequality x is less than negative 4. So again, it would be an open circle. It's less than, so you're heading to the left. Part B, x is greater than 0. Open circle, heading to the right. Part F says, darken the section of the number line where x is less than -4, so be this section, x greater than 0. So again, it would be this entire section again. So if you notice on this problem, these two don't connect in the middle. And if you look at the direction differences between C and F, the difference are the keywords and, or. And will always connect in the middle. Or is always 2 points going opposite ways. So in review so far, if you were to make a list of things different between and, or, in regards to true-false statements, with and, I'm in math class and English class, they both have to be true in order for the statement to be true. On the flip side, or means that only one of them has to be true. When we were solving, and can only have one solution. And remember, it has to be the same solution, or else it's no solution. Or we can have two solutions. When we were graphing them, and is connected, and or is not. So if you think about this, and has one solution, and has one line. Or has two solutions, and it has two dots going separate ways. Think about it. I'm going to New York, or I'm going to California. Two different directions, two different end destinations. Part G. Graph the compound sentence x is greater than -2. So that would be an open circle, heading to the right. Graph x is equal to -2. How we graph a number that's equal to is just simply a dot, and usually our dots are filled in. So if you look at this, now we have actually filled in that open circle. So part H asks if there's another way that we can combine these two inequalities, or if you want to look at the graph, if there's another way to write that. So think about how this sounds. X is greater than or equal to. And we have a symbol to represent that. Greater than or equal to. X is greater than or equal to -2. So if you think about it, we literally are saying these exact words. Greater than or equal to make this simple. This is to show you that this is a compound sentence that we can break into these two sections. Look at part I. This time they gave us the compound sentence and we're breaking it down. X is less than or equal to 4. So if you listen carefully, x is less than or equal to 4. And whether you graph these two or you graph this, you're going to still graph in the same way. Closed circle at 4, and you're heading left. Look at example 2. Graph each compound sentence on a number line. X equals 2. Again, if we're graphing it equals, it's simply just a dot. X is greater than 6. Well, 6 isn't on the number line, so we're going to make it. It's greater than, which means it's an open circle, and it's heading to the right. So use your knowledge of what you know between and or to confirm whether you think you've graphed this correctly. Or means, remember that you have two dots, two solutions. We have two solutions, and they're heading different directions. This one isn't heading anywhere, but this one is heading that way. Part B, x is less than or equal to -5. So it's a closed circle, it's less than or equal to, so it's heading this way. X is greater than or equal to 2. Closed dot, heading to the right. Again, this one's an OR, and we know that OR statements, we can have two solutions, which we have. We have two dots, and they're heading different directions. Part C. This is two inequalities that are written together, smushed together, written in a fancy way. Whatever is between the two inequality symbols is going to go with both inequalities. So in this case, x is in the middle. So x is going to go with this 1, that's one inequality, and x is going to go with this 3. So we're going to write each of those circles out separately. We have to graph these, and in order to graph an inequality, we have to have our variable out front. So if we move our variable out front, you have to take the sign in the direction that it is going towards the x. So if you look at this, the symbol is open towards the x, so the symbol needs to stay open towards the x. And this one is already set up nicely. So now we're ready to graph. X is greater than or equal to 1, so it's a closed circle, and we're heading to the right. X is less than or equal to 3. It's a closed circle, and we're heading to the left. So if you look at your arrows, we clearly need to shade between these two dots. And that is our final answer. Another fun fact is that things that are always written like this are always going to be ands. And you know what and always looks like. Two dots, connect. Exercise 4. Determine if each sentence is true or false. Explain your reasoning. 8 plus 6 is 14. Is 14 less than or equal to 14? Yes, that is true. 1/3 is less than 1/2. That is true. And our question here, or our key word here is and. And means that both statements have to be true in order for it to be true. And in this case, they are, so this is true. Part B. 5 minus 8 is -3. -3 is less than 0. That is a true statement. 10 plus 13 is 23. 23 cannot equal 23. That is a false statement. Our key word here is or. Or means that only one condition has to be true. And in this case, that one held us up, so this is true. Part C. Solve each system and graph the solution on a number line. So we're going to solve each one first. So to isolate our variable, we need to add 9 to both sides, which gives us x equals 9. The other equation, we need to subtract 15 to isolate the variable. So that gives us x equals -15. Our key word here is or. So we already know that it's normal to have two solutions, which we have. And we also know that it'll be two dots. And in this case, we won't have any arrows, but they will be in separate places. So if we draw a number line, -15 would come first on the number line, and then 9. We're going to just have dots, because it's not an inequality. So those would be our final answer. Part D, solve first. So we're first going to solve by adding 8 to both sides. So we're left with 5x equals -15. We're solving for x, so we divide by 5. X equals -3. Look at the other one. To isolate the x, we need to subtract 1. So we're left with x equals -11. So our solutions are -3 and -11. Again, the key word here is or, which means we will have two solutions, and there will be two different dots on a number line. So when we draw the number line, we will simply have dots at both points. Look at E. Look at E. These directions say graph each solution set to each compound inequality on a number line. X is less than negative 8, or X is greater than negative 8. These are already solved because the X, the variable, is by itself. So if we draw a number line and we have negative 8, let's take the first one. We have an open circle and it's less than, which means I'm heading this way. And then we have the other one. X is greater than negative 8. So we're taking the same circle and we're heading to the right this time. So use what you know to check. This is an OR statement, which means we technically have two different dots going separate ways. While this may look connected, it's not because there's a break on this negative 8. All right, look at F. F is similar to the last problem we had on the last example. The first thing you want to do is to split this into two. And remember, whatever is between your inequality symbols, you want to take both directions. So this X is going to go with the 0. And this X is also going to go with this 10. So rewrite both before you do anything else. 0 is less than X. X is less than or equal to 10. So before you graph this, you've got to write X out front. And the sign is opening towards the X, so you need to keep it facing that way. This one's all ready to graph. So on a number line, we have 0 and we have 10. We have an open circle on 0, and we're heading to the right. And we have a closed circle on 10 because it's equal to, and it's less than or equal to, so we're heading to the left. And as we know that this is a compound inequality, which means it's going to be an and, which means they are supposed to connect. And that's our final answer.